Today we will solve some problems on intersection of line and plane. So the first question is find the point of intersection of the line. The line is given as 2 minus x divided by 5 is equal to y minus 3 by 5 is equal to 2 minus z divided by minus 2. So find the point of intersection of the line and the plane x minus y plus z equal to 2. Now here we see that the line is not given in the standard form, so we will convert this equation into the standard form, and the standard form is x minus x1 by a is equal to y minus y1 by b equal to z minus z1 by c. So here this line can be written as x minus 2, and taking negative sign common, and we shift it to the denominator. So we have x minus 2 by minus 5, here we have y minus 3 by 5, and here we have z minus 2 divided by minus 2, that is 2. So here the negative sign which we have taken common from the numerator, it multiplies with the negative sign in denominator and it becomes plus here, right? Okay, now this is the line of equation of the line. Now here let us take the parameter lambda, and let us find the general point, the coordinates of the general point on the line, and the point can be determined by these three equations. X minus 2 by minus 5 is equal to lambda, then we have y minus 3 by 5 is equal to lambda, then we have z minus 2 by 2 equal to lambda. So from here we have x minus 2 is equal to minus 5 lambda, y minus 3 is equal to 5 lambda, z minus 2 is equal to 2 lambda. So from here we get x is equal to minus 5 lambda plus 2, y is 5 lambda plus 3, and z is equal to 2 lambda plus 2, right? Now these are the general coordinates of the general point on this line, and we have to find the point of intersection of this line and the plane. So here this is the plane, and the equation of the line is given here, and suppose the line passes through, this is the line, and say this is the point P, and suppose the point P has these coordinates for some value of lambda, right? Now since this point P lies on the plane, so therefore it must satisfy the equation of this plane. So if we substitute these values here, we get minus 5 plus 2 for x, then we have y, the value is 5 lambda plus 3, then we have z is 2 lambda plus 2 is equal to 2, right? So we have minus 5 lambda plus 2 minus 5 lambda minus 3 plus 2 lambda plus 2 is equal to 2, and here minus 5 lambda minus 5 lambda and plus 2 is minus 8 lambda, and here we have minus 1, and here we have minus 1 is equal to 0. So minus 8 lambda equal to 1, and lambda is minus 1 by 8, right? Now if we substitute this value of lambda here, we get x is equal to minus 5 times minus 1 by 8 plus 2, y becomes 5 times minus 1 by 8 plus 3, and z becomes 2 times of minus 1 by 8 plus 2. Now this can be written as 5 by 8 minus minus plus 5 by 8 plus 2, this becomes minus 5 by 8 plus 3, and this becomes minus 1 by 8, sorry, it is minus 2 by 8 plus 2, right? Now if we solve this expression, we get x is equal to 8 to the 16 plus 521 by 8. Y is 8 3 is 24 minus 5, that is 19 by 8, and the value of z is 8 to the 16 minus 2, that is 14 by 8, right? Therefore, the point of intersection of this plane and the line is given by the point P, and the point P has coordinates 21 by 8, 19 by 8 and 7 by 4, right? Now viewers, let us take this problem, find the point of intersection of this line and the plane. So here the vector equation of the line is given in the form of vector A plus lambda times vector B, and see here, if we convert this vector equation to the Cartesian one, we have x minus 1 by 3 equal to y plus 1 by 1 and z minus 0 by 0, right? Because this line passes through the point 1 comma minus 1 comma 0. Now the line is parallel to this vector B, so therefore the drs of the line are 3, 1 and 0, right? 3, 1 and 0, and the equation of the vector equation of the plane is given here, which can be converted into the Cartesian form as 3x minus y minus 7 equal to 0. Now we have to find the point of intersection of this line and the plane. So what we will do here, we will take a parameter, say r, right? And we will find the coordinates of the general point on this line L. So we have x minus 1 by 3 equal to r, y plus 1 by 1 is equal to r, and z minus 0 over 0 is equal to r. So from here we get x is equal to 3r plus 1, y is r minus 1, and z is equal to 0. Now this coordinate, that is 3r plus 1, r minus 1 and 0, satisfies the equation of the plane. So if we substitute this coordinate in the equation of the plane, we get 3 times of 3r plus 1 minus r minus 1, and here we have minus 7 equal to 0. This is 9r plus 3 minus r plus 1 minus 7 equal to 0. So 9r minus r is 8r, and 3 plus 1 is 4. 4 minus 7 is minus 3 equal to 0. So the value of r is 3 by 8. Now if we substitute this value here, we get 3 times 3 by 8 plus 1, then we have 3 by 8 minus 1, and here we have 0. So this is 8 ones are 8 plus 9, 17 by 8, and then we have 3 minus 8, that is minus 5 by 8, and here we have 0. So this is the required point of intersection of this line with this plane, right? So the coordinates are 17 by 8 comma minus 5 by 8 comma 0.